So we're going to talk about how to identify typical values and outliers in a data set. So the set I have here is the number of pieces of bacon people take at a breakfast buffet. So you go up, you have your plate, you can take whatever you want. How many pieces of bacon do you pick out of that tray and take with you? So we have numbers anywhere from 2 to 8. And I suppose the first logical and natural question you should be asking yourself is, why am I stalking people at a buffet and counting how much bacon they take? And well, I guess there are lots of answers to that, but the important one, if you're trying to run this buffet, I suppose, is how much does each person take and how many people are at the restaurant? So how much bacon do I have to provide every day? So bacon and meat and groceries in general are very expensive. So if you prepared enough bacon for every person to have 8 slices, I feel like you're going to end up throwing a lot of that in the garbage, and then your business doesn't do very well and or survive. So we've got to figure out a way to first measure how much bacon people are taking, and then we need to boil this down into a frame where I can say, well, some people take a little, some people take a lot, but this is the range that I can plan for. So we've already done a little bit of this because you started doing quartiles in the last section. So the first thing I'm going to do with this data set is to identify Q1, Q2, and Q3. And you've noticed I saved myself some work, and I've already put everything in order. You may have to do that step first yourself before you can proceed. So there are 1, 2, 3, 4, 5, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20 data points. So 20 data points. Marker, that's maybe not the best. All right, so 20 divides evenly by 4, so Q1 is going to be between the 5th and the 6th data points. So here I can see that the number halfway between 3 and 3 is 3. So my first quartile boundary is going to be 3. Second quartile boundary will be between the 10th and the 11th point. So in this particular set, halfway between 4 and 4 would be 4, so that's Q2. We also call Q2 the median, so I'm just going to label that in like that. All right, and Q3 will be this number halfway between there and there. So in this case, I have 4.5 as my Q3 value. Okay, so as far as typical values go, in a median style analysis, you've already done all the work because your typical values are anything between the Q1 goalpost and the Q3 goalpost. So you can just write that down right out the gate. So that a typical person, so that means like a generic person, not a specific person in the set, but if I were to imagine someone coming to my imaginary breakfast buffet, I would expect them to take between 3 and 4.5 pieces of bacon. Typical person will take between 3 and 4.5 pieces. So with a number like that, if you know that you serve 100 customers every day, you're going to need between 300 and 450 pieces of bacon available in that breakfast buffet. If you want to plan for emergencies, right, like over prepare, I suppose, because you would rather have the too much bacon problem than not enough, right? You can always put your leftovers in tomorrow's lunch, but if not enough people get enough bacon, there'll be riots, right? So based on this data set is telling me that because Q1 and Q3 are 3 and 4.5, a typical person will take between 3 and 4.5 pieces of bacon. if I'm trying to estimate on the over end to make sure I have enough, then 100 people at 4.5 pieces each, I should be preparing 450 in order to run my buffet. Now, if you look at those numbers, I've got 2s and 3s and 4s, and then there's this character. I mean, if you've ever been to a breakfast buffet, there's always this person hanging out in line, right? They get the bacon claw, grab as much as they possibly can, take plates and plates of meat. If you've watched that happen and you know that person is coming, you might be tempted to plan for that person. They might all be meat hogs, so let's buy 800 packs of bacon. But that's not cost effective, and I think you're going to end up wasting a lot of food. But nonetheless, there's this number sitting in your data set, and you are not allowed to just dump numbers because forget that guy. He's just a bacon claw. Don't worry about him. You have to have some sort of mathematical justification to ignore this data point when you're doing your planning. So that's where the concept of outliers comes in. So I'm just going to put that word up there. So an outlier is a data set or a data point in a data set that is so high that it really doesn't belong there. And that sort of thing happens all the time, right? You do have the bacon claw showing up, or you have people who fill out surveys incorrectly, like you ask for what grade someone is and they give you their age instead, or they're innocent mistakes. So we need to have some sort of system for giving us permission to dump those numbers if they don't look like they belong in the set. So under a median style analysis, the way you determine if a number is too high to belong in your data set is you take your Q3 value and you add 1.5 times your IQD. So in this case, my IQD would be 4.5 minus 3, which is 1.5. So I'm going to look at this number. I'm going to do 1.5, put it here. My Q3 value is 4.5. So my upper bound will be Q3, which is 4.5, plus 1.5 times 1.5. Why is this 1.5? It just is. It's this kind of a formula. You just run with that. Statisticians somewhere out there have decided that that's the appropriate value, so that's what we're going to use. This number is 1.5 because of our IQD. So this thing will change depending on your data set. So will this. If you just quick multiply that, 1.5 times 1.5 is 2.25. And 4.5 plus 2.25 is 6.75. So any data point higher than 6.75, higher than 6.5, I can't write as quickly as I speak, is an outlier. Which means you have permission to dump it. It's so comically high compared to the rest of the numbers that it's obviously not, doesn't belong there. So this fact that Q3 plus 1.5 times the IQDs gives you a number less than this, gives you permission to just vanish it from the set. And so now when you're planning for your bacon sales, you know not to think about that person, right? That's an anomaly, an outlier, a person who takes too much bacon. So you shouldn't be planning for them. You should be planning for these people. Okay, if you can do an upper bound, you can do a lower bound. So for the lower bounds, my face is probably going to get in the way here. It's the same idea, but you're taking the Q1 value this time and subtracting 1.5 times the IQD. So for Q1, I've got 3 here. 1.5 is always 1.5. My IQD is 1.5. So I'd end up with 3 minus 2.25 which is 0.75. So any data point lower, any data point less than 0.75 is an outlier. So I look at my data set. The lowest I have here is 2. So this boundary didn't exclude the 2s. It said those people are perfectly fine in your data set. In fact, it seems to imply that if you go to a breakfast buffet and take 0 bacon, then you are the outlier, which that's maybe a bit too political for math videos, but so there you've got it. You can take a data set here using Q1, Q2, and Q3 and the interquartile distance. You can now state a range where you should be able to plan for. Right? These are typical people, ordinary people's behavior. And you can identify extremely high behaviors and extremely low behaviors in order to remove those from their sets.